Hello, in this video we are going to implement several ideas from SOLIDWORKS Top 10 List 2020 from scratch. We explore a fundamentally new way of creating add-ins, command manager, property manager pages, macro features with new xCAD framework for SOLIDWORKS. We'll start by creating a new project in Microsoft Visual Studio. We can use C# or VB.NET. As a part of this presentation, I'm going to use C#. I need to specify the name of the project. Click Create, and it's going to create us a new empty project in Visual Studio. xCAD framework is available on a NuGet server. You can consider NuGet as a marketplace for libraries and frameworks where third-party developers and companies could publish their libraries for use. There might be a private NuGet servers, but in this particular case I'm using the nuget.org, which is a public server, and one of the benefits of that server is that libraries cannot be changed or removed retrospectively. So if you use a certain version of the library, you can be assured that you will be always able to access that library in your project. NuGet Package Manager is available in all Visual Studio applications, and you don't need to install any additional software to use NuGet. Let's navigate to Manage NuGet Packages command under the context menu of my project, go to Browse and click xCAD. I need to install xCAD for SOLIDWORKS. I can simply click the Install button, and it's going to bring me all the required libraries into my project. I have a simple README which helps me to get started. I can just copy that code and paste it into my project. If you've been developing SOLIDWORKS add-in from scratch, you know that there are certain things you need to do now to make that add-in registered in SOLIDWORKS. But believe it or not, with xCAD you don't need to do anything. So now I can just start SOLIDWORKS and we'll be able to see that our add-in is loaded into SOLIDWORKS application. We can see that message box has been displayed. That means that our add-in is now loaded. That was simple, but as it always happens with Hello World applications. And when you build the real world applications, this is where the cruel reality comes in, and you just understand that it's actually not that simple anymore. And I was thinking when recording this video is, what should I do to prove that xCAD allows you to build the real world application with the same simplicity as a Hello World applications? And one of the ideas come to my mind. Every year before SOLIDWORKS World or 3D Experience World, SOLIDWORKS is asking the community to submit the ideas they think worth adding to SOLIDWORKS. This list is called SOLIDWORKS Top 10 List. And let's now challenge the framework and implement several ideas from Top 10 List 2020 from scratch within the next 30 minutes. Let's take a look at our first idea, and this one is about built-in hide-show-bodies command in SOLIDWORKS. That command is slightly different from any other command, so it can be looked up in the commands, but it cannot be drag and drop on a toolbar, and it also doesn't have an icon. So the idea is about making that command look and feel of any other command in SOLIDWORKS. So in particular, we want to be able to add this into the menu, and we should be able to add a toolbar and command tab box. There are multiple ways you can implement that requirement. The easiest one is to just invoke that command from the button in SOLIDWORKS. Each command in SOLIDWORKS has its ID, and there is an API available which can invoke that command by its ID. The IDs are persistent across SOLIDWORKS sessions and releases. Unfortunately, there is no easy way where you can find the ID of the command. For that, I have created a simple macro which can just log all the IDs of the command invoked from SOLIDWORKS. So if I would click Edit Sketch command, you can see that its ID is 859. If I would call the bodies command, you can see that its ID is 1390. This macro is available on a CodeStack website, and you can find the link in the description of this video. Now let's go ahead and create our toolbars and menus. xCAD takes a very different approach of creating menus for SOLIDWORKS. So let me start with declaring the enumeration, and I'm going to call it TTL commands enumeration, and just define a field, call it hide show bodies. Now I'm going to bring a new namespace into my project, xarial xCAD UI commands. Now I can go ahead and create commands from my enumeration. I need to call add command group and pass the enumeration as a template argument of that method. I then can subscribe to command click notification, which will tell me when my command is clicked, and because I can have multiple commands into my command group, I can use a switch command to identify which particular command has been clicked. And now I should just implement my API to open the property manager page. I will be using run command API and pass the ID of hide show bodies functionality. I can put a breakpoint and start SOLIDWORks to check how it works. So before that, I'm just going to attach automatically to SOLIDWORks instance. For that, I need to copy the path to SOLIDWORks executable and specify it in my project properties. I can now use F5 to launch my project. Let's open part document. And as you can see, now we have a new command tab. We have a new menu with the command where the group name is named after the enumeration and the command is named after the enumeration field. When we click it, we can reach our function and invoke the API. As you can see, that just works. Of course, we would want to customize the look of our buttons. So for now, as you can see, it is using some default icon. It is named after the enumeration name and field name, and it doesn't look very user-friendly. So let's come back to our project and modify that. If you have ever developed SOLIDWORks add-ins with toolbars, menus, and command tab boxes, you might notice there's quite a lot of code associated with that. In particular, issues come when you need to specify the icon. You need to have a very specific type of an icon, size of the icon, you need to use a special key as a transparency, and let me show how xCAD framework is dealing with that. Let me go ahead and add my icon into the resources of my project. Just make it easier to redistribute my project as the resource will be inside the project itself. So let me go and switch to the images and add an existing file. I already have few icons prepared for this demonstration. So let me just select ones from my icons folder. So I just want to point your attention that this icon is in PNG format and the size is 64 by 64 and it has a transparency set up. In order to assign an icon to our command, we just need to use an icon attribute and we need to specify two parameters. First is the type of the resources our icon resides in, and the second one is the name of our resource. I'm going to use name of keyword to avoid any magic strings. In a very similar way, we can specify the name and the hint string for our command using the title and description attributes respectively. We can use the same set of attributes to assign the look for our command group. So in this case, I'm just going to specify the title to be TTL 2020. Let's start SOLIDWORks and see how it works. And as you can see now, we have a nice icon, title and tooltip for our commands in the menu, toolbar and command tab box. Let's go ahead and implement next enhancement from the top 10 list. And this one is about zoom to fit command. So built-in command allows us to zoom to the geometry, including the reference geometry. This could make it virtually unusable if you have a lot of reference geometry in your model. Let's go to our project and add a new command to our toolbar. So it is as simple as specifying a new field in our enumeration. So let's give it a name, zoom to geometry. You can change the title of that command. So for now, I'm just going to remove the description and add a new icon to be corresponding for that command. In a very similar way, I can select new image and assign the name of that image to be an icon for my command. I can then add a new case into my switch statement, so I can invoke the code when zoom to geometry command is clicked. To implement this command, I'm going to be using the zoom to region API, where I need to pass the bounding box of my geometry as an area to zoom to. With xCAD framework, I can use the API provided by the framework, so like in this case, I'm just going to be using that. But my previous command has been using the default APIs on SOLIDWORks. So if you can see, I was invoking the API from SOLIDWORks interface, while in this case, this API is invoked from xReal xCAD namespace. I just need to find the bounding box. I can use the calculate bounding box API, which is going to return me the precise bounding box of the model. And then I can just use an active view and call zoom to box API and just pass the bounding box I have previously calculated. Now let's see how it works. When we open part document, we can see that there is a new command added into our toolbar and command tag box. I can click to it and it just zooms to my geometry. So let me resize the plane and call it again. So you can see it is working as expected. Let's now look at our next enhancement, and this one is about adding a new functionality to create a chamfer on a shaft body by specifying the base radius and an angle. SOLIDWORks has built-in functionality to create chamfer, but unfortunately it is not possible to specify the base radius and an angle to create a chamfer. When developing applications, we should aim to provide the best user experience for our clients. So if you would want to implement that request as a best experience, I would go ahead and create a feature which resides in the feature manager tree, which could be edited, suppressed, removed, which has all of the parametric behavior, should provide dimensions which you can link to the design table or to the equations. It should have a preview when you're modifying parameter, and so on and so forth. That sounds like a very big project which could take some time to be implemented. And here I just want to talk a little bit about the project development approaches. There are two main concepts when developing a project. First one called waterfall approach, so where you develop the project up until the very last stage and then you release it to the users. And you have an agile approach where you try to iteratively develop the functionality and release it to the users as soon as possible. There are pros and cons of each of these approaches, but I would like to try implement that functionality with agile approach. We can split that project to three components. So the first one, we're just going to insert the simple cut revolved feature in our feature manager tree, and we'll ask our user to select the circular edge, and we might pop up a user form where user can enter radius and diameter. So as a next step, we might improve the experience of our users a little bit, and we're going to introduce a property manager page to collect input. So now instead of having a pop-up user form and asking our user to select the element, we can show the nice property manager page with selection box and number boxes. And as a last step, we can create what is called macro feature, which is a native element in the feature manager tree which behaves like any standard feature in SOLIDWORKS. So with macro features, you can effectively re-implement any feature already exists in SOLIDWORKS, such as extrude or revolve. And I'll show you how to do that a bit later. I will skip the implementation of the first step where we're going to use a cut revolve feature to insert our shaft chamfer, just because it's quite a simple API. You can simply use macro recording to find what API should be used. And I will go ahead and start with the second step where we're going to create a property manager pages. I absolutely prefer to use property manager pages in my applications to improve the usability and user experience. It provides a native look and feel of our application, and it's usually appreciated by the users. However, I hate creating property manager pages. It's just a lot of code I need to worry about to make my property manager page work. Not only I need to add a control, but I also need to constantly handle all of the notifications from my property manager page handler and update my variables in my data model. Let me show how xCAD deals with property manager pages. We'll start by adding a new class into our project. This class is going to hold the data required to create a shaft chamfer feature. Let's call it shaft chamfer data. We're going to use that class as a handler for property manager page. I need to make it public, and I need to inherit that from SW property manager page handler class from xCAD framework. I also need to make sure that this class is COM visible. Now we need to define the properties to collect the input from our user. So in order to create our shaft chamfer, we need to have an edge. Also we need to have a radius and angle. We would want to have a property manager page like that to collect our input data into our data model. Let's come back to our code and define a variable for property manager page. I would also define the variable for data. We can then create an instance of our property manager page on within the onConnect function, and we can just subscribe to closed notifications so we can create our cut revolve feature. It is also required to check what was the reason of closing of our property manager page. User can click a green tick or he can click cancel, so we only want to create our feature when user click a OK button. Now let me add another button into my toolbar so I can open property manager page when this button is clicked. I need to follow very similar procedure to add new button to my toolbar, so just create a new field in my enumeration, assign icon and title. In order to show property manager page to the user, I need to call a show method from property manager page variable, and I need to pass a data model into that method. So I'm just going to create an instance of my data model and pass it to that method. We can start the debugging process now and see what we have as a result. I'm opening the model. New button has been added to my toolbar, and when I click it, I have a property manager page created for me. But furthermore, it is considering my data model. So for example, my selection box already have an icon for an edge, and I can select an edge into that, and I cannot select anything else. I can also specify some numeric values into my number boxes. And when I click a green tick, I reach the on-page closed handler, and I can see that my data model has been filled with the values from my property manager page. I want to add some customization to my property manager page. So at first, I only want to allow selection of the circular edge into my selection box. So for now, you can see I can select a linear edge, but that doesn't make sense for creating our shaft chamfer. I also want to modify the property manager page title and also assign an icon, and as well modify the look of my numeric boxes. So I want it to look more similar to standard number boxes in SOLIDWORKS pages. So I want them to display my current unit of measure and allow some formulas in there as well. I can use customize filter logic to filter out everything but circular edges, but I can simply define my property as circular edge and framework will do the rest. I can assign the icons to my radius and angle numeric controls in a very similar way with icon attribute, but I can use a standard icons provided by SOLIDWORKS, so it will look similar to the default property manager pages. So for example, for my control corresponding to the radius, I can just select the radius icon and angle icon for my second control. I can use number box options attribute to provide some specific parameters for my number box controls, such as the units, minimum and maximum values, and increment. I can use exact same title and icon attributes to assign the icon and caption for my property manager page. So I'm just going to copy that from my command. And of course, I can assign the default values for my controls by simply assigning the default values for my properties. Now we can validate the result. Let's open property manager page. So we can see there is a new icon assigned to my radius and angle controls. I can specify the unit of measure, and I can only select circular edge into my selection box. Now let's implement our macro feature. At first, I want to remove the code which adds and shows the property manager page. That's a quite common thing for agile approach, as new functionality usually supersedes the older one, so just need to remove the code which you no longer need. Now I will add new class which is going to define my macro feature. I'm going to give it a name shaft chamfer macro feature def, and I need to make that class public and visible. I need to inherit that from SW macro feature definition. There are multiple overloads of that class, and I'm just going to use the one which allows it to specify the page and the data. In our case, I'm just going to be using the same shaft chamfer data class. Usually you might use different classes for your property manager page and your macro feature definition, but in our case, we're just going to use the same one. We only need to implement a single method in that definition, which creates a geometry from our input parameters. I need to import several namespaces to make our code compilable. And now I want to talk about macro feature added bodies. Because our macro feature is going to modify the existing body, we need to tell the framework that the input body is something which our macro feature is going to replace. So for that, we need to define a new parameter in our data and call it body of SW body type, and we need to mark that parameter as parameter edit body, so framework will understand that this body is editing body. We also need to assign that value automatically from our edge, because the body which belongs to an edge is our edit body. So rather than asking our user to select a body into the selection box, we can automatically assign that every time our edge is changing. To avoid creation of selection box for that parameter, I'm just going to use exclude control attribute to tell framework that control should not be generated for that property. Let's insert the macro feature into the tree by calling the create custom feature API. I will add breakpoint to our code and start the debugging. Let's create new part. Click on create shaft chamfer command. You see property manager page. Let's select an edge, and now you can see that our create geometry function is hit. So framework is calling that function as it requires us to generate a preview body to display to the user. Let me explain that code in a bit more details. So firstly, we find the direction of our chamfer. So we can find that by finding the normal of our planar face, which is connected to the selected edge. Now using the trigonometry function, we can find the height of our chamfer. Now we can create two primitive bodies. First one is a conical body with the height which we have just found, with larger diameter equal to the diameter of our shaft, and a smaller diameter equal to our input parameter. Second primitive body is a cylindrical body with a calculated height, where the diameter of that cylinder is equal to the diameter of our shaft. When we are dealing with macro features bodies, we cannot use feature manager APIs. We need to deal with the temporary bodies. Those bodies provided by iModeler interface, or in case of xCAD, we can use geometry builder interface. Temp bodies reside in memory and are very fast to deal with. You need to use simple Boolean body operations such as add and subtract to form the body you need. In our case, we can get the desired body by subtracting the result of subtraction of cylindrical and conical body from our input body. I also want to point out, if we would open the parentheses of that formula, that will be also valid to our end result, although the order of operation is different. xCAD provides a very simple way to implement the Boolean operation in the body, and you can write the formula directly. Now we can see that our body is generated and our preview is displayed. We can modify the parameters to see our preview updated, click green tick, and that will result in generation of the macro feature in our feature manager tree. To improve the usability of our feature, we can set radius and diameter parameters to be a dimension of our feature. You need to align the dimensions of your macro feature so they are properly rendered in the graphics view. You can use helper functions such as align radial dimension or align angular dimension to align the specific type of the dimension. For radial dimension, it is required to specify the center point and direction. For angular dimension, it is required to specify the center point of an angle, also a referenced fixed point, and the axis of rotation of our angular dimension. Now we need to mark these two parameters to be considered as dimensions. We need to use parameter dimension attribute. I need to specify the type of the dimension. So the first one we're going to use radial type, and the second one is our angular type. Let's now start SOLIDWORKS and validate the result. We can open the part and insert our macro feature. I'm just going to use default parameters. And now when I select the macro feature in the feature manager tree, you can see that two dimensions have been rendered. And I can use those dimensions in the exact same way as any other dimension in SOLIDWORKS. I can modify the value by dragging and dropping. I can modify the value from the pop-up form. I can also go and edit the definition of my macro feature, and you can see that all the dimensions are consistent. I can suppress that feature and unsuppress it. I can also apply another feature on top of that, and all of the parametric behavior is going to be preserved. So if I would go and modify the value of my angle, you can see that fillet is changed accordingly. As a last step, I want to show you how to assign an icon and the base name for our macro feature. In a very similar way, I can use title and icon attributes, and I can just copy paste them on top of my macro feature definition. I just want to update the title to be consistent with SOLIDWORKS naming convention. I have already saved the model from my previous step, so I should see my macro feature in the tree with a new icon. I can also modify its definition to validate that all of the parameters are preserved. Now let me remove that feature and insert a new one. So you can see now it is named according to the SOLIDWORKS naming convention for features. Thank you for watching this video. Please follow the links in the description for source code in C# and VB.NET and some more information about xCAD framework.